Of course.
So of course, there's always one person that screws it up for everybody.
It's like, on the surveyor's test, you used to take a full game,
I know.
and then they caught people cheating.
Mm-hmm. Now you can only take a little PI in there,
Yeah.
which you don't need it for the PS. They ask so many dang law questions that.
Really?
And the difference between an answer, one says was and the other one says is. And that's the difference between the, you narrow it down to two questions.
Yeah.
And that's the difference between the two. One says is and one says was. So you
That's what I'm thinking. All that stuff that way. It's pretty complicated.
It is. Okay, so all we need today is the whiteboard because that's all we're going to be doing is doing problems. So let me go ahead and put the whiteboard on. And I think I'm recording, so let me check to make sure. I think I hit record. Yeah. All right. So, with complete the square. In algebra, there's several ways to find the x-intercepts. One, you can do the factor by the reverse FOIL. But the problem with that is some things are not factored. Two, you can do it with the shortcuts. Three, you can actually solve an equation and find the x-intercept. It is set up to do that. But all three of these have one thing in common. The problem has to be what? It has to be set up for the FOIL, or it has to be set up for the shortcuts, or it has to be set up for the solving equation. Now, I like to tell students that the quadratic formula is used for a decimal, like 2.2 x squared minus 3.6x plus 4.7. That's what I like to tell students the quadratic formula is used for. And if you use the quadratic formula, that's good. Use it for the decimals. But the one that's not restricted and the one that's easy to use after you figure out how to do it is completing the square. It's not restricted. And you don't have to use a calculator. All you got to do is use your brain. Now, if you suck at basic math, then you're going to suck at completing square. Okay? But by the time I get through doing 10 problems, you're going to see how the method works. And then you'll be a little bit more intimidated. Now, have you seen completing square before? Where?
My last class.
Okay, 102?
Yeah.
Okay, how about you?
I don't think so.
Okay. Where'd you see it?
My last class.
102?
Actually,
Huh?
I'm retaking this. So.
Okay, so you've seen it before. Don't be, there's a lot of people taking this class before.
102.
102? In my class, okay. So, all of you have seen except for one, so that's all we're going to be doing for the next two classes. Probably do 5 or 6 today, probably do 5 or 6 next time, because there's two sets of completing the square. There's the easy ones, and then there's the hard ones. And we got to do the easy ones first so you can understand how to do it. Let me show you how to do complete the square, and I'll start with number 1. Number 1, the first thing you do is move C. The second thing you do is you add blanks. Third thing you do, and it's probably the most important, put a star beside it. B divided by 2 and square it. 4. After you put B divided by 2 and square it, you put that into the blanks. And I just usually just draw that. When you see the problem, you'll see what I'm talking about. Now, after you do number 4, number 5 you will either have on the left-hand side, you'll either have shortcut number 1, or you'll have shortcut number what? 2, based on the sign. That's why you do complete the square, so you'll have a shortcut. And on the right-hand side, you just solve by using your math. 6, vertex. Vertex and vertex form. And 7, solve for x. All right, so let's do a problem. You're given f of x is equal to, let's do something simple, x squared plus 4x plus 4. Now, first of all, completing the square gives us 3 things. First of all, you get the y-intercept from the first of the equation. Then you find the vertex. And ultimately, you get the x what? Intercepts. Now, let's talk about what's what. Well, C is your y-intercept. So you need to write down to the side over here. Y-intercept is 0, 4. Whatever C is. Now to start to complete the square in motion, you've got to set the equation equal to what? You got to plug in 0 for y. So 0 will turn it around. X squared plus 4x plus 4 is equal to 0. Now you started finding the x-intercept because you're plugging in 0 for what? For y, or f of x. Now, you start with number 1. Move C. Well, move C. Where do I move? It's on the left-hand side. Where do you think I'm going to move? To the right-hand side. X squared plus 4x plus blank is equal to -4 plus blank. And that's when you add the blanks. Now we're at number 3. Now what's B? So I'm going to go over here and I'm going to say number 3. 4 over 2 squared. 4 over 2 is what? And 2 squared is, and 4 goes here and here. So now you get x squared plus 4x plus 4 is equal to -4 plus 4. Now this just so happens to come out before. It's not going to do that all the time. Now we're at number 5. So what does the left-hand side always give us? Shortcut number 1 or number 2 based on what? Based on that sign. And this is shortcut number 1, which is x plus 2 quantity squared equals 0. And at that point, you can do the vertex. Now, 2 things about the vertex. One is you can get the vertex by taking the opposite of both numbers. Okay? So what's the vertex of this? Well, that'd be -2 and -0. Whatever this is positive would be negative. It's negative would be positive. So -2 and 0. So vertex. It is -2 and 0. How do you know that? Well, look what you learned in chapter 1. This is A. This is H. And plus 0 is J. Look, put it in vertex form. F of x, and that's this part right here, vertex form. F of x is equal to 1 times x plus 2 quantity squared plus 0. Brought the 0 over and set it equal to f of x. And that is the form that you studied in Unit 1, where this tells you what? The orientation, that's A. This tells you what?
Horizontal shift.
And this tells you the vertical shift. Okay. Now, this is intercept form. You need to write that down. This right here is intercept form. Now, the reason it's so important is some of the homework questions, some of the test questions are going to ask you to put it in your intercept form. And then some will just ask you what the vertex is. If it just asks you what the vertex is, you just take the opposite of this and the opposite of this. If it asks you for the vertex after you vertex form, you've got to take the opposite of this, which is -2, then just bring this down. Okay, so you've got two different things, and you'll see, I'll do it, the first 5 or 6 questions, I'll do it both, I'll do both.
You said on the intercept, the other one doesn't change.
When you pull it down, you just pull it down. So look, -2, I took the opposite, and the 0 just comes down.
But if it
So
were a 4, instead
it'd
of
just
4.
be 4, yes.
Okay.
We'll get to that one. Now, after the vertex, I'm going to erase this right now. Well, let me do this. Let me see if I can just highlight everything and make it smaller.
So you'll always get that shortcut on the left.
Always.
Like
Shortcut number 1 or
difference
number
of
2.
Squares or
Always.
some.
That's the whole point of doing complete and square. Oh, how much hard math have we done?
That's a pretty good.
Huh?
I mean, for me.
Well, it's not supposed to be. You're in college algebra. It's not supposed to be, and I'm not being mean or anything, but a college algebra student, this should be easy.
No, that isn't.
It should be. Somebody out of the 12th grade, this should be easy. But the problem is, we're teaching too much watered down math in high school. That's the problem. So here's my f of x. Is equal to x plus 2. No, I'm not going to do that. I don't think that. This form right here, I really don't like. I don't like to teach it to students, but I have to. I deal with this one right here. So x plus 2 quantity squared is equal to 0. Now solve this for x. Solve it for x. That means you got to take the square root of each side. I'll do the square root of 0 for you. There you go. So x, your x-intercept is what? -2. Is that always going to be just 1? No. Usually you're going to have 2 x-intercepts. We'll get into that later. So now you can sketch your graph. Zero, 4 is your y-intercept. -2 and 0 is your x-intercept. And -2 is also your vertex. So it looks like that. What's the range? The range is from 0 to infinity. What's the domain of all quadratics? All real numbers. All these quadratics, the domain you should not miss, because all real numbers. And then what is your decreasing values? from negative infinity to negative 2, and increasing from what? Negative 2 to infinity. And that's how you do complete the square. Now the problem is, they're not always going to be that easy. That's the problem. So we'll do another one here in just a minute.
Let me ask you this. On the intercept form, if they ask for that, they're asking for the f of x
is equal to x plus 2 quantity squared plus 0.
Oh, that's okay.
You're going to bring that 0, whatever this number is, you're going to bring it over, which changes the sign, and you're going to put f of x in front of it. That's it. I don't go out of my way to do that all the time. Okay, and I'm going to keep this here. And I'm going to erase this problem. Y'all mind?
And you drew the graph based on that.
Based on those three, four things. It's just a sketch. I mean, you should be able to ascertain what it looks like. Because A was 1, I knew it was a regular parabola. I knew it wasn't wide or compressed or anything like that. So let's do another one. Let's do x squared plus 6x minus 2 is equal to 0. All right, y'all do that one. What's the y-intercept? Y-intercept is 0 to 2. Half of 6 and 3 squared. And that'll give us shortcut number 1, x plus 3 quantity squared is equal to 11. I'll let you find the vertex, put it in vertex form, and then continue with solving. do you spell sever?
SEVERE.
That's severe. That's what I thought, but it didn't look right. Yeah. Okay, my vertex is what? -3, -11. Vertex form, I put it over here because I don't like to have it in my work. F of x is equal to x plus 3, quantity squared minus 11. Now solve it. Well, take the square root, x plus 3 is equal to positive or negative. I'm going to go over here to figure out 11 because I don't want to have to use my calculator. Because completing the square, you're not supposed to use a calculator. Okay, that's probably what teaches it. All right, so the square root of what? Square root of 3 is 9. The square root of 4 is what? 16. 9 and 16 is what? 7. Half of 7 is what? 3.5, so that's 12.5 right here, right? And that's equal to, I'm sorry, I'm doing the wrong thing, hold on. I'll just go over the thing fast like this. The square root of 14, or 16, is 4. The square root of 9 is 3. And the square root of 12.5 is 3.5. So I need to get closer, so I need to interpolate. You know, contour lines?
Yeah.
Interpolating, finding the middle of the middle of the middle. So 9, we said this was 3.5, half of 3.5 is 1.75, which would be 10.75 is equal to 3.25. So I'm gonna say it's around 3.3. And then x is equal to positive negative 3.3 minus 3. And what's $3.30 minus $3? 0.3. And negative $3 minus $3 is negative what? $6.30. So there are 2 intercepts. I'm sorry, 3.3 and 0, and then negative 6.3 and 0. So now, sketch it and tell me what's the increasing, decreasing, domain, and range.
Let me get with you on this. Okay. You took the square root of 11, so it was 3.3 roughly.
Mm-hmm.
So then you subtracted the 3 from it.
Well, you got positive or negative. Remember, with a square root, what's 3.3 times 3.3? 11. What's negative 3.3 times negative 3.3? 11. So whenever you take a square root, you've got the positive or the negative.
That's right.
So I brought this 3 over, and it becomes minus 3. So 3.3 minus 3 is 0.3. Negative 3.3 minus 3 is negative 6.
Gotcha.
Now sketch it and give me all that stuff that I said. Domain, range, increasing and decreasing. I'll do domain for you. Domain is all real numbers. So my y-intercept is 0, -2. My vertex is -3, -11, 0.3, and -6.3. And what does the drawing also tell you besides how to sketch the parabola? It will also tell you if you have made a what? Why will it tell you you made a mistake? It won't line up. To me, for a student in high school algebra, this is essential for them to go into calculus. Excluding trig, they use trig. They don't know how to do anything as far as completing the square. They don't know how to find vertex, they don't know how to do anything. This does everything. And you don't have to depend on that idiot box to think for it. Now the domain is all real numbers. The range is from negative what? 11 to what? Infinity. And decreasing from negative infinity to -3, increasing from what? -3 positive infinity. And that's how you complete the square. Now, I just did on a scale from 1 to 10, we just did 2 number ones. Okay? So you got 2 number ones. Let's do one. That's maybe number 2 or number 3. X squared plus 3x minus 2 is equal to 0. Go ahead and write your y-intercept down. And I will tell you this, we do not use decimals with completely squared. So that means you quit? Yep, pretty much. Because that means you can't use a decimal, you have to use what? And what does that mean? You quit. Yep. Yeah. He says one thing in my class about the windows. X squared plus 3x plus blank is equal to negative or positive 2 plus blank. What's half of 3? 3 halves plus 3 halves squared. Now how hard is that? Not hard at all. And what will that give you over here? Shortcut number 1. X plus 3 halves, 1 squared, is equal to 8 fourths plus 9 fourths. And class asked, where does the 8 fourths come from? You got to have, add fractions, you got to have a common denominator. And that's why people don't do it. That's why they do it. That and have to find the square root in the head. So x plus 3 halves, 1 squared, is equal to 17 what? Fourths. Write your vertex down. Now, if you want to change it to a mixed number for your plotting points, that's fine. So it'd be 1.5, comma, 4 and 1/4, 4.25. So our x-intercept, or our y-intercept, is 0, comma, -2. My vertex is 1.5, I'm sorry, negative 1.5, and negative 4.25. All right, finish it. Well, we've got to do that, so f of x is equal to x plus 3 halves, quantity squared, minus square root of 17 over 2. That's going to be your, no, 17 over 2. All right, now take the square root of both sides. That's going to be x plus 3 halves equals square root of 17 over 2. Now this is some hard math right here, because the square root of 16 is 4. So the square root of 17 is just incalculable. X plus 3 halves is equal to 4.1 over 2. And that's positive and negative. So your x-intercepts is equal to, x is equal to positive or negative 4.1 minus 3 over 2. And let's do our math in our head. What's $4.10 minus $3? $1.10. And what's half of $1.10? 55 cents. That's right, guys. 55 cents. That's one x-intercept. You owe somebody $4.10, and you owe somebody $3. You owe them $7.10. And what's half of $7.10? $3.55. And there's your other x-intercept. So sketch it. and I'll entertain questions. Now you see why teachers don't teach completely square? You've got to use your brain. Same effect, give somebody 16 as a plus register, same effect. X-intercept, y-intercept is 0, -2. Vertex is negative 1.5. Negative 1.5, put it right in there. Down, negative 4 point whatever. No, the y-intercept is on that back. Negative 2, and 0.55 is up here. And negative 3.55, well, that's 2. Or 1.5, so, what's the domain? All reals. What's the range? Negative 4.25 to infinity, decreasing from what? Negative infinity to 1.5, negative 1.5, and then increasing to negative 1.5 to infinity. So we just did the number 2 or 3. So let's do another 2 or 3. I'm going to go to another page. I think y'all seen that in a minute. X squared minus 5x minus 4 is equal to 0. Give y'all 5 minutes. 5 or 10 minutes. So we've got 2 number 1s and this is 2 number 2s. So that means we're heading to number 3 now. Ellis,
Yeah.
yeah, he was here. Grant, Hall, she was here. Kharkiv, Lindsay, she's not here today. Rusnick's here, Sob's here. Say she has a sick child. And Skipper is not. How are we doing? You finished yet? Oh, you just, okay, you ready for the window? Okay, what's the y-intercept? Okay, y-intercept is 0 negative 4. X squared minus 5x plus blank is equal to 4 plus blank. 5 halves, quantity squared, is equal to what? 25 what? 25 fourths. And that'll give you shortcut number 2. And fours be 16 fourths plus 25 fourths. X minus 5 halves is equal to, I have no idea, 31 fourths. Okay. Now vertex.
So how did you
Okay. And now we're going to change, somehow I changed from, this thing hits me, there's no, does somebody want to explain to me how I've changed from eraser to highlighter? $41 over 4. All right, what was your question?
I'm just confused on your fractions.
Okay, go back.
You got 25 over 4.
Mhm.
Okay.
5 over 2.
Yeah, I understand how you got 25 over 4. How did you factor that?
Shortcut number 2. Take the square root of the first term, square root of the last term, take minus b upon the square.
You said the square root. Okay, so big. Okay.
See, the square root of this is this, because you squared this
Yeah.
with this. So this is the number you're going to be using each time. Right there.
Okay.
The vertex is 5 halves, comma, negative 41 fourths.
How is the vertex? Have I done this long before? I've never done this long.
I'm sorry, what?
I just don't understand how you get the vertex.
You just take the opposite of these two numbers.
Yeah, just like a lot of people like that. I can do that every time that's like
You don't understand what?
how the vertex.
Well, remember in the last unit, this right here, and that's the vertex form right here, f of x, is equal to x minus 5 halves, y squared, minus 41 over 4. So what is this? Let me get my highlighter out. What is that right there? From unit 1. The horizontal shift. What is this? This is vertical shift. This right here is vertical shift. So if you take your horizontal shift and your vertical shift, you got what? The vertex. Okay? But when it's in vertex form, you take the opposite of this and you bring this down. So the opposite of this is what? 5 halves, and you bring that down. When it's in this form, you take the opposite of both. That's why I like doing this, because students remember that a whole lot easier. You take the opposite of both. But the homework and the test asks that you put it in that form. Any other questions? All right, now we've got our vertex, we've got our y-intercept, now we just got to find the x-intercept. x minus 5/2 is equal to square root of 41 over 2. Well, square root of 36 is what? Square root of 49 is 7. 36 to 49 is what? 13? Half of 13 is 7. 7, 36 or 6, whatever, 6.5. 6.5 is 42.5 is equal to 6.5. What do we need? 41, so I'm going to say it's around 6.3, 6.4, somewhere around there. So x minus 5/2 is equal to positive or negative, what I say, 6. It's 42.5 to 6.5. Yeah, 6.3. Somebody check it then. And then x is equal to positive or negative 6.3 plus 5 over 2. What's the square root of 41?
6.4.
Okay, it is 6.4.
This would just work with ugly numbers.
Yeah. And they're going to get uglier by the time we get to 10.
I'm slightly worried because you see that.
I'm sorry, what?
I'm slightly worried because this is pretty bad.
No, this ain't nowhere near. When you throw a couple of negatives in there and throw all three of them fractions, and then you got 1 and 3. These are all below 5 because 1 is in front. And when that's not 1, you have to factor out, and that's where you get 6, 7, 8, 9, 10.
You're gonna have like less.
No, you'll probably have a good many though, because this is one thing that I hammer in Unit 1 is complete disclosure. By God, my college algebra students and calculus, they know how to do complete square, and the rest of the class is like, hold on, how do you do? What are you doing there? They know how to do it. So you'll learn it. It's just like anything else. That you see it, you'll learn it.
It's good. You know how to do it. It's just the number that
Yeah.
I get the process. I don't know what-
Well, I'll be honest with you. This is where you'll have a problem. This is where you'll have a problem. And right in here is where you'll have a problem. Why? Because you're dealing with numbers that 4th and 5th graders can do. Or 7th graders, whatever you want to call it. And you're taking away that cash register. You're taking away that security blanket. That's why. And that's why people can't make challenge. Now, I'm being facetious, but it's the same concept. Same concept.
We've been kind of sharp.
Yeah, it's your teacher's fault. It's not your fault. It's Bruce's fault. X is equal to, what's $6.40 plus $5.40? $11.40 divided by 2 is $5.70. That's x of 1, that's your first x. X of 2. What's negative $6.40 plus $5? Negative $1.40. Well, just go ahead and put negative there. Now, $1.40 divided by 2, 70 cents. There's your x-intercept. You're telling on yourself, you better be quiet.
Yeah, this is gonna take a little
This
while.
is 3 worse than
Huh?
This isn't calculated for the radical grades.
Nope.
For the square root.
No. You need to be able to do it in your head. I mean, it's not that big a deal. I mean, you telling me you can't take the square root of 36 and square root of 49. Even if you don't have a clue, you can say it's 6.5, because it's in the middle.
Well, yeah, but they don't use that.
Well, it won't be exact, but it'll be better than you work it or do it relying on the calculator. Because calculus, we haven't even got the calculator out yet.
What's the most known about that?
We don't. Here we don't. Because you don't need it. Because everything you should be able to do. What would you think of an engineer that didn't know how to make changes?
I had one professor basically hammer how to use a calculator and how useful it was, and then at the next class, next to like, oh, you're not allowed to use that.
It is, okay, let me answer this.
Wait, what was the point of that last class then?
Yeah, some professors push it so much, the calculator, because they can use something.
That's it.
And then other ones don't allow you to use it. You know, and you use it as a crutch last time, or use it as an all nice feature.
Well, I tell my students, like well, it's just like anything. What do you pick out of your toolbox to drive a nail? Screwdriver? No, you pull out a hammer. You pull out a screwdriver to drive a screw in it. You pull out a saw to cut a board. You don't pull out a you don't pull out a hammer to saw a board. You don't pull out the calculator every single time you do a mathematical equation. You use it to speed up a process. Now, I'll give you an example. Didn't I tell y'all to pull out your calculators and graph some things a while back? I did. Because nobody walks around and thinks about, let's see, where does x intersect x squared? Nobody ever thinks about that. Nobody. All right? So that's where you need a calculator, where you don't have to take the time to go out. Now, do I let students use a calculator when I'm teaching graphing? No. But y'all should know how to graph. So I let y'all use that so you can take some time. Now that's a hammer with a nail, okay? In probability and statistics, there's 2 or 3 formulas in probability and statistics that takes you 10 times longer than using a calculator.
Yeah, you just put it to list 1 and 2 and so.
Exactly. And that is a screwdriver or a screw. But you don't use a calculator to take the square root of 25. And you don't take a calculator to add 16 plus 25. And I've got a lot of students that use it. And they can't. And that's what they should have been doing in 6th and 7th and 8th grade is learning how to do those fractions and not learning how to do them in a calculator.
Really, the only thing I would use is the calculator for in the order of That's really the only thing I would have done. And the first one where we had the radical 11, that threw me off. So I'm used to that at least being like maybe radical 12, so you can work with it a little bit.
Yeah.
But that radical 11, like that's just one of those numbers.
But
And same thing goes.
But can you do this? You
Yeah,
can.
in my head, I can get close.
And what's going to happen is after about the 4th or 5th time you do this, you're going to start catching, and you're going to start saying, well, it's above 5 and it's below 5, so it's going to be below 6.5 or whatever. You're going to start putting a relationship between this number and where the square root falls based on this number right here. You're going to start doing that, and eventually you'll start saying, okay, the square root of 51 is 7.3, or yeah, 7.3, because 51 is a little bit above what? 49. Eventually you'll get it.
It's a little more work.
It won't be after we do 10 problems.
But what about on the home UNC?
Well, I'm gonna get to that. When we get to number 10, I'll get to it. All right, so here we go. 5.7 is over here. Negative 0.7. Now, what am I doing? I'm sketching. Does it matter if I'm off? Not by a point or two, no. Now, when you're doing homework questions,
The homework's not forgiven. So.
yeah, so you got to use your radical. You're probably going to be using your radical more than your calculator. All right. But am I teaching you this so you can pass a test, or am I teaching you this so you know where the daggone thing is at the calculus? I'm teaching it to where you can put it in your paper, on your paper in a minute. See, calculus, you can do this. Okay, that's what I'm teaching you. I'm not teaching you to regurgitate on a test. I'm teaching you this, and I'm teaching you this, and this. So when you get calculus that first couple of weeks, you can put a parabola on the paper without having to go through an act of Congress. That's what I'm doing. Okay, now, if this falls on a test, yes, all you got to do is subtract the stuff that I'm telling you to do in your head with the stuff, the radicals, and most of the time, it's going to stay a radical. And we'll get to that when I get to the end of completing the square. But right now, my priority is to teach you how to complete the square and how to do it without the help of a calculator. Okay? So, let's 0, -4, right here, and the vertex is what? 5/2, which is 2.5 and 16, or what is it, 10 and 1, 10 and 4, which is down here. And like I said, the drawing will tell you what? If something's wrong. Alright, so that's 2 number 2s, or 2 number 1s, 2 number 2s, whatever. A number 3 would be, or number 4. We could do number 4, yeah. Number 4 would be a negative in front of the x squared. So let's do that. Anybody got a question? Alright, so, okay. Why are we doing this? Why didn't change my major to underwater basket weaving? Negative x squared minus 2x minus 4 is equal to.
Depends on what kind
Okay, I'm sorry, underwater firefighting. I'll change my degree to underwater firefighting. That's what people do. All because they can't do freaking fractions.
So we can thank those teachers that were lazy.
When you
and just
see
said,
them,
"Put it
you
in
say,
calculator."
I really appreciate you screwing me over in 5th, 6th, and 7th grade. Thank you. My daughter and my son, they know not to use a calculator all the time, because I'll
I'm sure you've seen on the Common Core.
Common Core is good if it's done right. I teach Common Core. 49 times 3 is 147. Okay? That's Common Core. That's what Common Core is supposed to be. What these people are teaching, I have no idea where they're getting that from. Common Core is taking a problem that's an ugly number, like you said, and making it a pretty number, and then subtracting or adding, whichever one you want to do. That's Common Core. What I'm teaching with the radicals, that's Common Core, because you're using your brain. It's called interpolation. You do it with that.
Is that actually the word?
Interpolation.
You come out with square root.
Yeah. Find the middle of the middle of the middle. It's called the mid-range or the midpoint. You find the midpoint of the midpoint of the midpoint, you can find any number you want. Now, is it exact? No, it's not exact, but you can get it to the 10th. Okay, that's all you need is to the 10th to sketch.
Good enough to draw a graph on.
Huh?
Good enough to draw a graph.
Yeah, good enough to draw a graph to let you know what's going on with that parabola. Yeah, all this 49 times 3, and you do all this, and you have all this, and you did all this, and then, I don't know what's that is. But that's what happens when a bureaucrat gets involved in something.
So you take the 4 out, take the 9 out, you separate them, multiply by 4, and divide by 4.
So you gotta have somebody to explain that to the teachers, and that's what the bureaucrat
It's
does.
not making it easier, making it harder.
Yeah. First thing to do is move C. Now, at this point, you need to say A is not equal to 1. A is equal to -1. Therefore, we have to factor out a common term. And you're going to factor out a -1. Now, the only catch to that is whatever you factor out, you have to multiply by the right-hand blank. All right, whatever you factor out, you need to multiply by the right-hand blank. So I'm going to factor out a -1, right? And that's going to give me x plus 2x plus blank is equal to 4 plus -1 times blank. Okay? Now, a lot of people say, well, why didn't you make this a positive? Well, heck, I don't know what this is. This could be 0. It could be -4. It could be 5. I don't know what it is. I'll let the negative tell me. I'll let the 2 tell me. and then I'll figure it out. And plus, whenever you divide something and square it, if you square something, what is it always going to do? Positive, so that's another reason it's positive. Okay, because it doesn't matter what you're going to do, you're going to end up adding.
This would be pull the negative one out before we do that.
Mm-hmm. Yes. Now that A is 1, I can do complete and square. So complete and square. I picked the easy one for you. 2 divided by 2 is 1. 1 squared is. And now you got negative 1. X plus 1, quantity squared, is equal to 4 minus 1 is. Now finish it.
Wait, I'm confused
Tough.
on the right side.
Where
You, okay, that's just where you multiplied it.
you do not ask that question. Are you asking why is the negative 1 multiplied by the blank? No.
I'm not sure what you're saying.
Okay.
I'm saying you multiplied it by the right side by -1.
Yes. This guy
Yeah.
has always got to be right here inside this blank.
Okay.
Now the reason is, the original complete and square does everything on the left-hand side. That's why. I don't show how to do everything on the left-hand side, because the original method of completing the square is very confusing to students. You can do it on the left-hand side. So that's why I don't show that. Just take my word for it.
So you just
Whatever
keep
you
it-
factor out here, goes right there.
But you just bring it down on that one.
Yeah. Because that's your A. This tells you that it's a regular parabola and it's opening which way?
So,
From unit 1. Y'all trying to get unit 1. I know you all. All right, finish it.
We move back to both sides, obviously, like this.
Huh?
We move back to everything both negative.
We're going to get to that.
Then you're gonna get imaginary numbers, and
Then that means no x-intercepts.
but then the window is, then the window is.
Yeah.
We get to that.
Imaginary numbers is all, it's just the reason we use I is so that you can add I and subtract I and multiply I. That's why. And it's a whole lot easier to write the square root of -1. That's why we use I. So here I've got a vertex of -1, -3. That's my vertex. And my y-intercept is 0, -4. And now we solve for the x-intercepts. -1, -1. X plus 1, quantity squared, is equal to -3. Now at this point, you need to highlight that negative. And you need to go out to the side and say no x-intercepts. Because in the radical, under the radical, it can be positive, it can be negative, and it can be 0. That's called the discriminant. Write that down, the discriminant. I don't know how to spell it, but I always want to put an N in discriminant. I don't know if it's discriminate, I don't know, but I'll try. Discrim, no. I want to put an N in it. All right, the discriminant is what's under the radical. If it's a positive, that means you're going to have 2 x-intercepts. Which means a parabola, just like that. Or it crosses the x-axis 2 places. The negative says no x-intercepts, which means you got a floater. Somewhere out there in the quadrants floating. And 0 means you have 1 x-intercept, which means it's sitting on the what? It's sitting on the x-axis. So, with this problem, we don't have any x-intercepts.
It just looks like it's flipped upside down and both.
Yeah, so it should be down here somewhere. It should be either down here or down here, somewhere down in the 3rd or 4th quadrant. Yeah, just come on in over, that's fine. Oh, you early? Oh, you for the next class, I'm sorry, that's fine. What time's the next class start? What time? No, what time's this class over? Okay, so, how do you finish this? Well, this is where the radical comes in. You finish it by saying x plus 1 is equal to, I'm going to put the square root here, x plus 1 quantity squared is equal to the square root of -1 times the square root of 3. Because what is -3? -1 times square root of 3 times -1 times 3. So, what is the square root of -1? I. And the square root of -3, you can just leave it square root of -3, and then bring the 1 over. And that's how you would write the answer for I, or imaginary number, or non-x-intercept. The square root of -1 is equal to I. And the reason you use I is so, and we'll talk about that after we complete the square. The reason you need I in case you add, subtract, multiply, divide I's. And you will do that in more complicated math problems. So this is a floater. My x-intercept or y-intercept is 0, -4. My vertex is -1, -3. And which way is it opening? So it's a floater. That means it's opening downward.
So how did you determine to graph that, just roughly,
How did I determine what?
to graph that point?
Well, you only got 2 points. You got 0, -4. Then you got -1, -3. And which way is the point opening?
Okay, so you didn't use your eye that well. Okay.
All right, this is a number 3 or 4. So we'll do another number 3 or 4. You got to remind me where we are. Number 3 or 4, and that'll be probably a negative with a fraction in here. Okay? I already called the roll, so y'all good to go. Y'all can leave whenever. I gotta stop the do-jigger.
Does the online teach you anything like this? Or
What
have you
online?
asked the online work?
Yeah, all it tells you to do is complete the square. I don't know how they teach you to complete the square. If they teach it all on the left side or they teach it on both. I don't know, but it should be, you should come out with the same answer. I don't know, we'll have to look at it, I don't know.
Yeah. Because that's the one problem I've had is you learn it one way and you go online and it's like complete